In this lesson, we're going to look at some applications of our vertex coloring. So the first thing we have now is you are working for an explosive company, meaning that a company that deals with explosives. Your job is to make sure that all of the explosives at the company are safely stored in warehouses. Some of the explosives cannot be in close proximity to others, so some explosives cannot be stored in the same warehouse. To reduce expenses, we want to use as few warehouses as possible. The table below shows the explosives that cannot be stored together. How can a graph be used to represent the explosives and the conflicts between each? Well, we know that if we have any object, right, and it is connected in some way, that they cannot have the same color. So if we look at something with explosives, right? For example, explosive 1 cannot be with 2, 3, or 7. That means if we have a connection between 1 and 2, 1 and 3, and 1 and 7, they are not going to end up in the same warehouse. So let's go ahead and map this out. So let me move this over a little bit just so that it's closer to our table. So we have 7 explosives that I've gone ahead and labeled here, and we are going to look at how they cannot be stored. So I'll make the connection between each. If you can, go ahead and pause this video and use this chart to go ahead and make your graph. If you get stuck, follow along for the first one, and then pause it again and see if you can get the remainder. All right, let's take a look at the first one. It cannot be stored with 2, so there's going to be a connection there. Cannot be stored with 3, so there's a connection there. And it cannot be stored with 7, so there's a connection there. If at this point you kind of understand what we're talking about, go ahead and pause this and complete your graph. With 2, it cannot be stored with 1, 3, or 4. 1, 3, or 4. So I've got 2. 3 cannot be 1, 2, or 4. 1, 2, or 4. So we got one more connection there. Number 4, explosive 4 cannot be with 2, 3, 5, 6. 2, 3, 5, and 6. So that's 4. 5 cannot be with 4, 6, and 7. 5 cannot be with 4, 6, and 7. And then 6 cannot be with 4, 5, and 7. 4, 5, and 7. And then 7 cannot be with 1, 5, and 6. So it looks like we have them all done. All right, so now it comes to coloring. And so I'm going to go ahead and start with 1. And I look at what's next to it, and obviously it cannot be the same color. So I'm going to go ahead and color this as a 2. Well, if I look at this next one, it's connected to yellow and it's connected to green. So I can't have either of those colors, so I'm going to have to pick a third color. So here I have a color of this pinkish magenta. Okay, so now I'm looking at this one. I have it connected with pink and I have it connected with green. And I don't necessarily know what this connection would be or with this connection, but I do know that this is the most number of connections I've got. Now, because my 6 and my 3 are not connected, I can go ahead and make that 6 into a magenta. Even though they're both connected with 4, they're not connected with each other. Okay? And with 4, we have that connected to green and magenta so far, but I don't have a connection between this yellow and that one. So I'm going to go ahead and use yellow to mark that one. Then I'm going to move on to the next color here. I'm connected to a yellow and I'm connected to a magenta, but I am not connected to a green. So I'm going to go ahead and put a green in there. And then my last one, this is where I'm going to run into, I think, a challenge. I'm connected to green, I'm connected with magenta, and I'm connected with yellow. So I am going to have to go with a fourth color. Okay, so those are our colors, okay, that will not be duplicated, or that you don't have two adjacent ones that are the same. Let's see here. We drew our graph. Explain what each of the graph means. Okay, so let's go ahead and write what those are. So our vertices are our explosives, and that's 1 to 7. And then our edges are explosives that should not be together. Explosives that should not be with another. And then our colors. What would our colors represent? Go ahead and pause this video and see if you can determine what those colors are, and we'll come back. All right, our colors are going to be the warehouses. So anything that's in yellow, because they are not connected, meaning that there's nothing that prevents them from being together, would be together. The greens would be together, and then my magentas would be together. And then I have this blue one here that's going to be off on its own. Okay. How can the warehouse be represented in the graph that you constructed? Well, that's the colors. Use your graph to find a way to safely store the explosives using as few warehouses as possible. Explain how you are sure you cannot safely store the explosives using as few warehouses. Explain how you are sure you cannot safely store the explosives using as few warehouses as possible. Explain how you are sure you cannot safely store the explosives in fewer warehouses. Well, what we did is we looked at the minimum number of colors with our vertices. So there's really no way to get fewer colors, so therefore we know that we have the fewest number of warehouses. Okay? So that would be our solution there. Let's come down here and look at example 2. So Kylie has started collecting tropical fish. She has 6 different types of fish. Here's our 6 different types of fish. In fact, I'm going to move these over here a little bit. Alphas, betas, certas, deltas, epsas, and fetas. Because of predator-prey relationships, water conditions, and size, some fish cannot be kept in the same tank. The following table shows which fish cannot be together. So what we're going to do is similar to the explosives. We're going to put links between the ones that cannot be together. So let's go ahead and get started. I'm going to label these A, B, C, D, E, and F. So A cannot be with B or C. So I'm going to go ahead and make those connections here. So that's done. B cannot be with A, C, or E. A, C, or E. C cannot be with A, B, D, or E. C cannot be with A, B, D, or E. D cannot be with C or F. So C and F are off limits. E cannot be with B, C, or F. E cannot be with B, C, or F. So we've got that. And then F cannot be with D or E. So it looks like we've got our relationships here. All right. So our vertices are our fish. Our edges cannot be in same tank. And then our colors are going to equal the tanks that we have. All right, so let's go ahead and get started. So with A, I'm just going to go ahead and fill that in with yellow. Looking at our next one, that's going to be a new color, so I'm going to go ahead and put green in there. When I look over at this next one, it's connected to yellow and it's connected with green. So I'm going to need a third color there, so I'll go ahead and make it blue. Let's see here. So we have, I'm going to go ahead and skip over to this guy because it's already connected to a green and a blue. It is not connected to a yellow, so I'm going to go ahead and put a yellow in there. And then we have this one connected to a blue, and that's all it's connected to other than this one. So we've got some decisions to make. We know that this one cannot be yellow because it's connected to a yellow here. So let's go ahead and make that a green. And we know that it's not connected to this green, so we're in good shape. So when we go back to this one, if we're connected to a blue and we're connected to a green only, we can make that yellow. So we can have 3 tanks. All right, so there's that application. Before we head to the next page, go ahead and make sure you have this all done and then flip the page, see what you can do, and we'll go over it together.